Previously, we took a look at activation functions. Now, we'll take a look at optimizers. Every optimizer that has been implemented has a published paper that you can easily find and read up. The optimizer itself is a way of reducing the loss or cost to the network or model. The actual implementation of the optimizers vary, and the result of the optimization is dependent on the dataset that you're working with. The loss function is also a major determinant of whether or not the model could be optimized. As a result, a lot of effort has gone into finding loss functions that could be differentiated because minimizing loss is based on gradients, which are computed using differentiation. This technique is called gradient descent. There are three categories of gradient descent. Batch, which works by computing a gradient using all the training data. This works well on small data sets used for teaching, but is completely impractical for real-world solutions. Stochastic. This computes a gradient on one example drawn from training data. This leads to wide movements in the loss. Mini-batch. This computes a gradient on a small subset of training data. The batch size is normally a power of 2 and is dependent on the capacity of the processors. Consider the code on the screen. We've seen this lots of times. The first line creates our model. Second line sets an optimizer, a loss function, and a metric. We'll come back to that soon. Third line trains our model. Notice the batch size parameter at the end. This is how we set the number of training examples that get passed to the optimizer. Let's take a closer look at the optimizer, which we specify when we compile our model. We previously specified our optimizer by name. This causes the default values of the optimizer to be used. In the code on the screen, we create a stochastic gradient descent optimizer. We've already installed TensorFlow and imported the necessary modules. Notice we could specify parameters. First parameter is the learning rate, second, momentum, and the third is whether or not to make use of Nesterov momentum. It's a good idea to search for the paper published on Nesterov momentum and read up on it. Further down our code, we could see how we make use of our optimizer in our model. When we specify the parameters in the compile step, we then go ahead and train our model. Notice that we specified a batch size of 32. Go ahead and take a look at all the details of how long it takes to train our model and how our loss reduces. Using the same optimizer, we could train a new model with different batch size. In this case, we'll set it to 128. One thing to note here is that increasing the batch size reduces the amount of time it takes to train our model, but there is a limit to how large our batch size can be. Next, we make use of Atom Optimizer. The parameters are slightly different from those of stochastic gradient descent. You can read up on this optimizer from the published paper. We can proceed to train the model and observe the differences that were introduced as a result of our changes. Finally, we make use of the Add a Grade optimizer. Again, I suggest you find the paper that introduces this optimizer and read it. After training this model, we can inspect all the differences in training speed and improvements in loss and accuracy. We're going to be reviewing cost functions in the next video.